Hi, so for this session we'll be factorising monic trinomials, and I'll explain what we mean by a trinomial and by monic as well. But a key word in trinomials is this here where you got tri, and tri just means three. Like triangle, we have three sides, so just keep that in mind when we look at a trinomial. Now this is an example of a trinomial, and this one is a monic trinomial because the coefficient of x squared, so the number in front of x, is 1. So when we have this, these types of trinomials are quite easy to factorize because the coefficient of x squared is 1. And it's a trinomial because we have three different things. We have an x squared, which is different to the x, and of course we have this one sitting here, the constant. So it's got three different, so this is really a quadratic. If I put a y here, y equals, we have now a quadratic equation that is in a trinomial form. Quadratic equations, for example, we could have y equals x squared. This is also a quadratic equation, and we know that quadratic equations have the highest power, which is 2. We have an x squared and an x squared. If we had any power higher, then it wouldn't be a quadratic. We could also have another example of a quadratic equation. Just say we have x squared minus 2. And we've looked at these. To factorize x squared minus 2, we would have to use the DOPS method, difference of perfect squares. But you can see how this is not a trinomial because we don't have the x. We have x squared and the constant. It's missing just the x variable. And one more, I guess we can also have a quadratic equation that looks like this: x squared, say plus 2x, and no constant. So it's got the x squared, the 2x, but the constant, the number sitting on its own, is not there. And these ones here are quite easy to factorize. You can see that all we're going to do is really take out the x as a factor, and that's no problem at all. Now, to factorize a trinomial, we will first expand a binomial, so we've got two brackets here, and then factorize the simplified answer. So first of all, let's expand this. So we know that to expand, we go x times x and x times 2, and of course 8 times x and 8 times 2. So x times x is x squared, and then we've got x times 2, which it's all positive, so positive 2x. 8 times x, positive 8x, and 8 times 2, it's positive 16. Now we simplify this, so we have the 2x plus 8 to simplify, so we have x squared plus 10x plus 16. And we have our, I guess our final answer where it's simplified. And it's a trinomial, the x squared, the x, and the 16. Now we have to learn how to get this trinomial and put it back into its, expand into this form here where it hasn't been factorized. When it hasn't been expanded. And so to do this, we need to factorize. So before we try and do this, let's think about how x squared plus 10x plus 16 can be placed into these brackets. The first step is, well, we can see that to get x squared, we had to go x times x. So really the first step with these types of trinomials is get your brackets ready, 2 brackets ready, and the first thing is, well, x times x. That's your first step because you know to get x squared, you have to have x times x. And that's your first step. Now, because it's all positive, well, that's easy. We can just add in positive straight away. Sometimes they're not all positive, so that's where you have to be careful. Now, to know what numbers to put in here, we know that the numbers in the brackets, so the numbers here, we have 8, we had 8 and 2. And we know that 8 times 2 gave us 16. And here it is 16. So the numbers we put in here, when multiplied, have to equal the constant, the number sitting on the end. And we have to think of factors of this number, in this case 16, that can also add to the 10 or the 10x. Because if you have a look, we end up adding, in this case, the 8 and the 2, because 8 times x gave us the 8x, and x times 2 gave us a 2x, and we added these to get 10x. So the factors of 16 have to also add up to 10. So to do this, So if that confused you, we'll just have a look and see how we'll do this one. So I have to think of something times something to give me 16. Okay, that's our first step. So which is, what are factors of 16? Well, I know that 16 times 1 gives me 16. 4 times 4 gives me 16. 8 times 2 gives me 16. And I think that's it. So now we have to now look at, okay, so 16 times 1, yes, it gives me 16. But which one of these factor pairs will be able to add up to 10? Now, sometimes it's not possible, but we have to do a check. Just have a look. Because I have a positive 10, okay, let's test it. Well, I know that 16 times 1 gives me 16, but 16 plus 1, does it give me 10? No, it can't. 4 plus 4, does it give me 10? It can't. So I can't use this or this. 8 plus 2, does it give me 10? Yes, it does. But it also gives me 8. 8 times 2 also gives me 16. So they will be the numbers I put in here. And that's it. And we can see how, if we expand this, like we did up here, we'll end up with 2x plus 8x. So the 8 plus the 2 gives us 10x. And of course, 8 times 2 gives us 16. So a way to remember how to do this is, this is how I have sort of like a riddle, and that is a number times another number that adds to 16 to give you 10. So let's try another example. First of all, we can identify that we have a trinomial. We've got an x squared, a 3x, and a minus 10. So first step is, well, because there's no number in front of the x squared, this one should be easy to factorize if it's possible. So get your brackets ready. And next step is, I know that to get x squared, I have x times x. So that's my first step. Now, I can't just put plus and a plus, because you notice that we have a negative here. So just keep that in mind. So now, what are some factors of 10? I know that 1 times 10 is 10. I know that 5 times 2 is 10, or 2 times 5. And I think that's it. So now, which one of these is it possible to get 3? Whether we add or subtract, which one is possible to give us 3? Well, if I go 10 plus 1, it gives me 11. If I go 10 minus 1, it gives me 9. There is no way that can give us 3. With 5 and 2, well, 5 plus 2 is 7, but 5 take away 2 gives me 3. So it's possible for the numbers 5 and 2 to reach 3. Now, so far we know we have to use 5 and 2, but is 5 going to be positive or negative? So to do this, have a look at the 3. 3 is positive, so we have to get a positive 3 with the 5 and 2. And we also have to end up having a negative 10. And we know to get a negative, we have to have a negative and a positive being multiplied together to give us a negative. We can't have, for example, 2 negatives, because 2 negatives gives us a positive. And of course, 2 positives will give us a positive. So one has to be a negative, one has to be a positive in order for us to get that negative 10. And so far it's working out well, because, well, if I have plus 5, I use my 5, and then the minus 2, let's check it. 5 times a minus 2, yes, it gives us minus 10. And 5 minus 2 will give us the 3. So if you want to double check, expand this, and you'll notice when simplified, you get this answer here. And just before I forget, the whole point of factorizing a quadratic equation, so if I added a y here, we have our quadratic equation. The whole point of this is, when we look later on, when we look at parabolas, so I'll just draw a quick graph. Sorry that it's crooked. Later on, we'll learn how to find the x-intercepts. Now, I can look at this equation here that's been factorized, and I can actually see what the x-intercepts are. If I solve these, I'd have x is equal to negative 5, and here I'd have x is equal to positive 2. And this is telling me my parabola has 2 x-intercepts, where for one of them, x is negative 5, and the other, x is positive 2. As a quick sketch, I can draw my parabola, going through those 2 points. So that is the whole point of factorizing. And we'll learn this, we'll understand this a lot better later on. But just keep in mind that there is a point to factorizing, and it links to drawing parabolas. And we can know that with parabolas, it's possible to have two x-intercepts. And with this one, they are the x-intercepts of this parabola. Okay, with this trinomial, once again, we can just always check there is no number in front of the x squared. So our first step will be to get our brackets ready. And we have our x here and our x there, because x times x is x squared. Now, I can't just put plus and plus because unfortunately we have a negative sitting here, and that we can see that. So notice also we have here for this one a positive 3. So whenever you see a positive constant, in this case plus 3, the number on the end is positive, you have to know straight away for that to be a positive, you either have, in here, you either have a positive and a positive, because when you multiply those numbers, it'll be positive, or you can have a negative and a negative. They're your only options. So if I put a negative and a negative in here, depending on what numbers I have, it'll be minus something times minus something. That will give me a positive. Okay? So straight away I know for this one, there has to be two negatives in here because I've got a positive here, but a negative here. Now, to do this, so we're going to think of, okay, something times something to give me 3, that adds to negative 4. So obviously something times something to give me 3, the only option is 3 times 1. That gives me 3. And is it possible for 3 and 1 to somehow get to 4? Yes, I know that 3 plus 1 gives me a 4, but the 3 and the 1 obviously have to be negative. So minus 3 and minus 1, because if I put them in here, they'll be negative. And minus 3 minus 1, yes, it does equal negative 4 when I combine them together. So I have factorized this. And like I said, if you expand it, you can see what's going to happen. Minus 3 times minus 1 is positive 3. Minus 3 minus 1, or minus 3x minus 1x, will give us a negative 4. Now, with this trinomial, you notice that it is, at this stage, it is not monic because the coefficient of x squared is a negative 2. You can see this negative 2 here. And the problem with having a number here is, if you go to put it in brackets, you can't just put x times x, because we don't have x squared only, we have a minus 2 sitting here. So one of these will have to be a 2. But then the problem is when you expand, just say we had a plus 1 here, you're also going to have 2x times that 1, which ends up being 2x. And that's where it starts to get a lot complicated. But luckily for this one, we can actually take out negative 2 as a factor. So I'll just rub this off. So sometimes with trinomials, always do a check and see if it's possible to take out to take out the coefficient, the number in front of the x squared, as a factor. And by taking it out as a factor, in this case, we won't end up with fractions, which if we do end up with fractions, it'll make it more complicated for us. So taking out negative 2 as a factor, now this is where you have to be careful. Whenever you take a negative outside the brackets, you must do the opposite of whatever operations you have inside. So if I take out a negative, this will become a plus, this will become a plus as well, because when we expand it, it will give us a negative. So if I take out negative 2 as a factor outside my brackets, I end up with, well, x squared, because the negative 2 is outside now. Then I have a plus, because a negative times a positive will give us a negative. Now, 20 divided by 2 is 10, or 10x, and 18 divided by 2 will give me 9. Okay, and always please double check. If you go minus 2 times x squared, minus 2 times 10x, and minus 2 times 9, we will get what we started off with. Minus 2x squared, minus 20x, minus 18. So just double check. Now, the whole point of taking out the 2 as a factor is, if we look inside the brackets now, we have a trinomial where the coefficient of x squared is 1. Now, this negative 2 is outside as a factor. You can just forget about it. It will just sit there for the rest of the question. We now have to factorize what we have inside the brackets. So don't let this -2 confuse you. It's just out there now and it'll always stay out there. And later on we'll learn whenever you see a factor outside the brackets, it actually tells you, it gives you an idea of what the parabola will look like. And the larger your factor outside the brackets, the more narrow your parabola will be. You can just say they're two different parabolas. That's more narrow than this one here. But we'll look at that later on in the unit. So, to factorize this trinomial inside the brackets, now that we have no number out here besides 1, all we're going to do is get our brackets ready. And see this -2? I'm just going to write it out here. That's where it's going to stay from now on. So x times x will give me x squared. And guess what? We've got positive and positive. So everything is just going to be positive. And now this is the fun part. Something times something to give you 9 that adds to 10. So let's write down some factors of 9. I know that 3 times 3 is 9. I know that 9 times 1 is 9. And I think that's all the factors. So which out of these two factor pairs, which ones are possible to get to 10? Whether you add or subtract, which ones are possible? Well, 3 plus 3 is 6, and 3 take away 3 is 0, so that's impossible to get to 10. But I know that 9 plus 1 will give me 10. So these are the factors I am going to use. And because it's all positive, just chuck them in here, 9 and 1, and we're done. And it doesn't matter if you put the 1 here first or the 9, because it will still give you 10. And yeah, that's it for this one. So don't get confused that -2 is just out there now.